Hello YouTubers. I'm writing a small kind of wiki, classiccomputing.eu in German language, but you can also use Google Translate if it's working. I don't know. Classic Computing EU, and you will find some information about MSX computers, how the operating system and memory map and this stuff. And I try to combine to combine the learnings of myself and try to put them into this wiki. But I do not guarantee if it is all correct what I'm saying and writing on there. And today I want to make some experiments, some tests regarding call machine code. So if we have put assembly code into the memory, we want to try to start these using the user function of BASIC. You see on here. Yeah, it's annoying, this thing, and how this behaves when a BASIC program calls assembly program, which is stored in memory. I have to prepare my racing machine MSX. Cool thing on there. Maybe this part now it's a little bit boring, but I enjoy ramping up this thing. Let's change the color, then it's easier to see for you. We will load the champ assembler into memory and run it. It's on there on tip. We have to wait until this goes to 40. Yeah, so we have 35 counts time to prepare our mind. Well, actually I have to. I will switch back to the German version, so the hints are not disturbing. So what I wrote on here, you see how using a basic program opcodes could be entered straightforward into specific memory locations in a small loop. But now, using the champ assembler, we will write an assembler program which stores a specific opcodes to a specific memory location, and then we will try to load the machine program. We will define a user function and give the address and then call it, and then see. And the idea of this video is to get an idea about how while the call is performed, what values are written in which memory locations at MSX computers. So if this is the function on here which is called, the X is evaluated by BASIC, and it determines if it's an integer or if it's a double, or a double with double accuracy, right? Or if it's a string. And the result of this is stored in the address hex F663, and the value stored in this address could be value 2, value 4, value 8, or value 3, which indicates it's an integer or double accuracy, and a string function. So now the champ is ready for us, and we will try to write a small program. Yeah, display mem while user one call, right? So this is our program, what's going on there. we will put on this thing, we will put it as C000, and we will make also some variables. The type of this thing is stored at address F663, and we will call also a BIOS function to type out the value. It's chout, and it stands at address A2. At the start, we will load into the accumulator the content of the type, and when this program is called, then in the accumulator stands the value which is injected by BASIC, right? And no, it's wrong. It's not which is so we are inserting a value by BASIC, and the type of, if it's an integer, is stored in the address of type, right? Now, if we look at the ASCII table of this thing, yeah. So if BASIC says, hey, this is an integer, it will put the value 2 on there, and it would output this one here, but somehow this is not printed to the screen. I don't understand why. But nevertheless, we should increment this value by a value that we are coming into the range of digits. It's on decimal 48, which the corresponding hex value is 30. So we will add to the content of the accumulator the value 30, and then we will call chout and we will return, right? Ja, ich glaube, das war's schon. Let's oops. Oh. So let's assemble this beauty. Now you see here the address C00. It's starting. You see again C00 type, or yeah, it's not incrementing the addresses as long it's not putting opcodes into the memory, right? So this is just the output what we have typed in the source code, and these are pseudo operations or pseudo opcodes, right, in the assembly language. As soon we use the load instruction for the accumulator, it starts to translate this one here to opcodes. And you see here the opcodes for load the accumulator is the value 3A, and the value, the address on here type, is translated to 63F6. See this here, 63F6, yeah. This is this little endian or big endian stuff. I don't know if this one is big endian or little endian, I don't understand. But it's inverting the low with the high bytes somehow, and then it's adding the value 30 hex to the content of A, and it's C6 is the instruction for add a value to accumulator and the parameter 30 over there. And then there's a CD, is a call function to the address of chout A2, and this is then 00A2, and the return is C9. Okay, it's a simple table, blah blah blah, and the same complete, no errors. Okie dokie, we are in business. Let's try. Good. Yes. So in BASIC, now we are back in BASIC, right? So now we will define a user function which starts at C000, yeah. It's def user1, okay, and when we call now this function, and if you are now injecting into the assembler program, yeah, an integer value 5, yeah, it loads the value 2 from this register or from this memory location where it has figured out the type, right? So if we call the same function with a floating value, let's do this, we will see the value 4. So let's go upwards. Let's say 5.6, yeah. Now it's reading off 4, right? So when the assembly routine returns, then BASIC looks again into the memory locations where it previously stored information in. While the user function call, it writes the type of the parameter into a address and writes this value also in another memory locations. We will have a look in the next step. And if the assembler program comes back again is in the same memory location looked at by BASIC, and the value is put into the resulting variable a, right? Yeah. So this means if we now type in a string as a parameter, then it will indicate on here the type 3 because it has realized that this one here is a string. When the assembler program comes back, it tries to put the result, the string hello MSX, because it's in the same memory location. It's now treated as the result memory location. It tries to put into the variable a, but this is not a string variable, there's not much room, so it's come type mismatch, right? So if you now say that a is a string and call this beauty of statement, then you see that it's just an OK prompt, right? So there's no type mismatch. Yeah, make a small moment. So a string equals user1 MSX rock and roll. Yeah, so type okay. So in the variable a string, this is, but this is not written by myself inside. It is in the memory location which represents the return value of the assembly program. So, and now as a next step, we will have a further look at this additional. So this is this table with this address F663, which is the type of the parameter value. So and now we will have a look on the memory location F7, F8, F7, F9, and this is string F7, F8, and there I don't know where we will end up. Yeah? So, but let's try, because it's now time for experiments I wrote in there. So let's see what's written in these two memory locations when we transfer the value 5 as an integer to the assembler program. Right? So now let's go. User 1, this is the starting address of jump. Now we will call jump. So edit mode. This is the load byte equals to the address F7, F8, and the high byte equals to the address F7 F9. Okay, and now we will load not the type, we will load low byte, output it, and then we will load high byte. We will add 30 again to get into the range of these digits you remember. Yeah, so we see here, yeah, because we won't be able to see these outputs here, I don't know why. And again we will call out and then return, so we can see what's in low byte. This is the first one, and then high byte. Okay, assemble it again. Let's go easy. Okay, quit the program. Yeah, and now the user one equals easy. And now, so now we will put 5, right? And it's outputting 5 and 0. So in the low byte the value 5 is stored and the high byte 0. Okay, so let's do 220. Oh, okay. So now we have a question mark on the Z, yeah? Question mark on the Z. Question mark. I'm looking now here where I can see it. Here. Question mark on the Z. Yeah. There. It's the value 168 minus 48. It's 120. Oh yeah, this is this one here. 120. So this one is there. Okay, but the high byte is still 0 because our byte has not written to the upper nibble, right? So let's do 220. Oh, bad. I messed something. I don't know. I think that this basic stuff has interpreted something, right? I just play it. Oh, 200. Achso. 100. As soon as the high byte, which value would it be? High byte, it's 128, right? No, 256. Nee, 2 hoch 8. Wait a second. 2 hoch 8. Doch, nee, 2 hoch 8 ist doch. Okay. 2, 0. Und hier, it's always writing value 0. Low byte, high byte. Seven. I think that something is wrong. The fuser one. I'm always messing this up. So. I will use this value here because this is Also basic call, we have now overwritten the contents of these variables by the call to jump again, right? So we will dump f663, oops, wait, dump f663 f6, I'm stupid, f7 f8 to f7 fa, let's say, so like this. So, and now we see the value DC, and here's indeed. And what's DC? Let's move. Let's use the calculator. We have to switch to hex, and then we will write D, and then we will write C if I find it, and convert this to decimal, and it's 220. Yeah, so on here it's written, but when it will write into this memory location, friends, but this is from 1 to 200, so this is from 1 to 255, from 0 to 255. Okay, moment. Right? So this is bigger than in 1 byte is storable, right? So again, let's go to the monitor again. This assemble address F7 F8 to F7 FA. You see, 40 and 01. Okay. Let's go again out, good, yes, and try again from basic. Def user, okay, now it has written the letter P and the letter 1, right? The letter P on here this, I don't know where, these are all capital letters on there. I don't know how to translate now P backwards. No, I'm stupid, friends. I was watching over there to find capital letters, but the lower on the other side. So you see here, P, the letter P is 112. So make a small calculation. It returned us the letter P, 112. So 112, right? We need to subtract the hex value 30, which is decimal 4864. We have to add this second byte over there, which is set. We have to add 256. And you see here 320. Ta-da! There it is. This is the representation of it.
Cool, excellent. I will try to make now the video and upload it to how it's called, YouTube, to YouTube. And the other things over there, with the string and so on, we'll have next time. See you. Bye.